We like to think of our planet as a finished map, a fully explored house where every corner has been swept and every shadow accounted for by our satellites. But the Earth is far older than our maps, and it possesses a memory that stretches back into a cold, chaotic era when the rules of biology were still being written. Deep within the clockwork of our solar system, there is a ghost that haunts the outer reaches of Saturn, a world that technically shouldn't even be there. This is the story of Phoebe, a dark and scarred wanderer that defies the elegant, synchronized dance of the other moons by moving stubbornly against the cosmic flow. For thousands of years, our ancestors looked at the stars with nothing but wonder and naked eyes, unable to see the tiny specks of rebellion hidden in the dark. It wasn't until the 19th century that a silent revolution in glass and silver allowed us to capture light over hours, revealing secrets 4,000 times fainter than human sight. In 1898, atop the dry and thin air of the Peruvian Andes, the Bruce telescope began staring into the southern sky, waiting for something small to move. Back in Massachusetts, human computers pored over photographic plates with magnifying loops, hunting for a needle of light in a haystack of infinite black. William Henry Pickering found that needle, a faint, flickering dot that moved with Saturn but refused to follow the established orbital etiquette of its peers. This was Phoebe, the first natural satellite to be discovered not through a lens by a human eye, but through the patient, chemical memory of a camera. As astronomers began to plot its course, the initial excitement turned into a profound scientific confusion because Phoebe was breaking the most fundamental laws of the system. Most things in our solar system spin and orbit counterclockwise, following the original momentum of the swirling gas cloud that birthed the Sun and the planets. Phoebe, however, orbits in retrograde, moving clockwise like a driver going the wrong way on a celestial highway, a smoking gun for a very violent history. In the cold logic of orbital mechanics, a moon that orbits backward is a moon that was stolen an immigrant, snatched from the darkness, and held prisoner for eons. It sits staggering 13 million kilometers away from Saturn, so distant that if you stood on its surface, the famous rings would be invisible to your eyes. For nearly a century, Phoebe remained a blurry enigma, a jagged dark blob that even the Voyager probes could only glimpse from a vast, frustrating distance. Everything changed in 2004 when the Cassini spacecraft began its final approach, a high-stakes arrival that offered only one brief window to meet this lonely sentinel. Cassini had to scream past at nearly 6 kilometers per second, knowing that once it entered Saturn's inner gravity, it could never return to the edge. In those few frantic hours, the dark dot transformed into a complex, battered world, revealing a surface that looked more like a battlefield than a moon. What we found was a time capsule from a period of solar system puberty, when the giant planets migrated and the very foundations of space were torn apart. To understand Phoebe, we have to look past its scarred exterior and into its very heart, calculating a density that shouldn't belong to a moon of Saturn. Most of Saturn's regular moons are fluffy, porous balls of water ice floating through space with the density of a snowball. But Phoebe is heavy, clocking in at 1.63 grams per cubic centimeter, suggesting it is more than 50% solid rock. This chemical fingerprint tells us that Phoebe is a planetary embryo, a tiny world that began to grow into something much larger before its evolution was frozen in time. It didn't start its life here. It was born in the deep freeze of the Kuiper Belt, far beyond the reach of Neptune's current orbit. We know this because Cassini spectrometers sniffed out carbon dioxide trapped in its rocks, volatile chemicals that would have vanished if it had formed near Saturn. Phoebe is a survivor of the Great Planetary Migration, a period of cosmic upheaval where the giants Neptune, Uranus, Saturn, and Jupiter played a game of musical chairs. As these behemoths shifted, they acted like gravity slingshots, flinging millions of icy bodies into the sun or out into the lonely interstellar void. Phoebe was one of the lucky ones, a wanderer that happened to pass too close to Saturn's massive gravitational net and was snagged forever. But this captured prisoner hasn't been sitting quietly for 4 billion years. It has been waging a subtle, dusty war on its neighbors. For eons, Phoebe has been bombarded by micrometeoroids, tiny cosmic bullets that blast dark dust off its surface and into the vacuum of space. Because Phoebe's gravity is so weak, this dust escapes easily, forming a ghost-like halo that stayed hidden from human eyes until the year 2009. Using the Spitzer Space Telescope, we discovered the Phoebe ring, a structure so gargantuan it makes Saturn's famous main rings look like a child's toy. This ring is an invisible monster, spanning a volume of space so large you could fit nearly 1 billion Earths inside of it. If your eyes could see infrared light, this ring would appear twice as wide as the full moon in our night sky, a glowing, tilted crown for Saturn. This massive dust cloud solved one of the oldest and most frustrating riddles in the history of astronomy: the mystery of the two-faced moon, Iapetus. Since 1671, we've known that Iapetus is a celestial yin-yang, with one side as white as fresh snow and the other as black as coal. Now we realize that as the dark dust from the Phoebe ring spirals inward, it slams head-on into the leading face of Iapetus. Phoebe is effectively spray painting its neighbor from millions of miles away, acting like a cosmic vandal over billions of years of orbital history. It is a reminder that in the solar system, no object is truly an island. Every world leaves a fingerprint on the space around it. If we want to understand the true mystery of Phoebe's arrival, we have to look at the solar system not as a static neighborhood, but as a violent, shifting puzzle. For most of human history, we assumed the planets had always occupied their current seats, orbiting the Sun in a peaceful, unchanging arrangement. But modern physics and computer simulations, like the NICE model, suggest a much more dramatic past, where the giant planets once lived much closer together. Imagine a cosmic dance, where Saturn and Jupiter suddenly fell into a gravitational resonance, tugging on each other with the force of billions of suns. This orbital tug-of-war sent shockwaves through the solar system, pushing Neptune and Uranus outward into the vast, icy reservoir of the primordial Kuiper Belt. As these giants plowed into the outer disk, it was like a bowling ball hitting a million icy pins, scattering ancient objects in every conceivable direction. While most were lost to the dark, Phoebe was a tiny fragment of that original chaos that was snagged by Saturn's gravity during the peak of the migration. This makes Phoebe more than just a moon. It is a pristine laboratory sample of the material that existed before the Earth was even fully formed. It is a planetesimal, a building block of a world that never was, preserved in a deep freeze state for over 4 billion years. But even as a prisoner of Saturn, Phoebe is slowly changing, revealing its secrets through the scars and landslides seen on its asphalt black surface. Cassini's high-resolution cameras showed us bright white streaks cutting through the darkness where the outer layer of dust had slumped away. Beneath that thin veneer of dark carbon lies a heart of water ice, suggesting Phoebe is a giant, dirty snowball wearing a dark, protective coat. The surface is so saturated with craters that every new impact simply erases an older one, creating a landscape that is effectively as old as time itself. Dominating this battered world is the Jason crater, a massive impact basin so large it nearly shattered Phoebe into a billion pieces upon impact. The fact that Phoebe survived such a cataclysmic blow tells us it isn't just a loose pile of rubble, but a solid, differentiated body with internal strength. This internal structure is the key to why Phoebe is so special. It represents the middle ground between a simple asteroid and a fully realized planet. It is a window into the differentiation process where heat from radioactive decay once melted its interior, allowing heavy rocks to sink and light ice to rise. This process was cut short when the moon cooled down, leaving us with a biological and geological fossil of the early solar system's grand ambitions. If we could land on its surface and dig just a few hundred meters down, we might find ices that haven't seen the sun since the dawn of time. But for now, Phoebe remains a distant sentinel, a dark intruder that reminds us of the time when the heavens themselves were being torn apart. As we peel back the layers of Phoebe's history, we realize that its existence challenges our very definition of what a moon is supposed to be. In a solar system where most bodies formed in neat, predictable circles, Phoebe is a reminder that the universe is messy, chaotic, and full of travelers. Its retrograde orbit is more than just a quirk of physics. It is a permanent scar of a capture event that happened before the first life emerged on Earth. Think of Saturn as a massive, swirling whirlpool, and Phoebe as a piece of driftwood that was caught in the outer eddies, never to reach the center. This distance is key to its preservation, as the intense radiation and heat of the inner Saturn system never reached far enough to boil away its history. We find ourselves looking at a world that is chemically identical to Pluto or Neptune's giant moon Triton, but trapped millions of miles closer to us. It is as if we found a piece of the Antarctic ice sheet floating perfectly preserved in the middle of a tropical, sun-drenched ocean. Every time a tiny rock hits Phoebe, it releases a puff of primordial dust, continuing to build the invisible ring that paints the rest of the system. This process of ballistic pollution is a rare example of one moon actively changing the appearance of another across such a vast distance. Without Phoebe, Iapetus would be a uniform, boring grey. It is the Intruder's dust that gives it the striking contrast we see today. But what does this tell us about the future? If Phoebe was captured so easily, what other objects are currently hiding in the dark? Our telescopes are getting better, finding thousands of small, irregular moons around Jupiter and Saturn that follow similarly lonely, backwards paths. Each one of these is a story, a captured fragment of the great migration that shaped the world we live in today. We are beginning to see the solar system not as a series of isolated planets, but as a vast, interconnected web of shared material and histories. The Phoebe ring was invisible for centuries because we weren't looking in the right wavelength, proving that the most massive things can be hidden in plain sight. It makes us wonder what other gargantuan structures are currently orbiting our neighboring planets, waiting for the right sensor to reveal them. Science is often the process of realizing that the void between objects is actually teeming with dust, gas, and the ghosts of dead worlds. Phoebe serves as a bridge, connecting the familiar ringed giant of our backyard to the mysterious, frozen frontier of the Kuiper Belt. It is a messenger from a place so far away that light itself takes hours to reach it. Yet it sits right here, orbiting a planet we know so well. As we move forward, we must ask, how many other intruders helped build the environment that eventually allowed our own world to thrive? As we stand on the threshold of a new era of space exploration, Phoebe remains one of the most compelling reasons to keep looking outward. It is a world of contradictions. A moon that is actually a planet, a neighbor that is actually a stranger, and a dark object that reveals so much light. What lies beneath those ancient landslides? Are there pockets of liquid water trapped deep within its rocky core, heated by long-dead radioactive isotopes? Could the organic materials found on its surface be the same chemical precursors that eventually sparked the engine of life on our own blue marble? We don't have all the answers yet, because Phoebe is a difficult host to visit, sitting at the very edge of where gravity and chaos meet. But every time we look at Saturn, we must remember that the planet's beauty is not just in its rings, but in the dark sentinel guarding its gates. Phoebe reminds us that the solar system is not a finished masterpiece, but an ongoing process of capture, collision, and slow, dusty transformation. It tells us that even the most solitary and battered objects have a voice, singing a song of a time when the giants themselves moved the stars. Perhaps the most profound lesson of this dark moon is that being an outsider doesn't mean you don't belong, it just means you have a different story to tell. In the grand theater of the cosmos, every moon, no matter how small or how wrong its orbit, is a vital witness to the history of everything. As our probes venture further into the Kuiper Belt, we may find thousands of Phoebes still waiting in the dark, untouched by the gravity of giants. We are essentially looking into our own past, seeing the raw materials of existence before they were baked and molded by the inner sun's heat. Our journey to Phoebe was a brief, frantic flyby, a few hours of data that will fuel centuries of human curiosity and scientific debate. It leaves us with a sense of cosmic humility, a realization that we are living in a system that is far more dynamic than our ancestors ever dreamed. The mystery of the Dark Intruder is a reminder that there is always more to see, provided we have the courage to look where the light doesn't reach. We are the only creatures on this planet capable of wondering why a moon moves backward, and that wonder is our greatest evolutionary tool. So, the next time you look up at a ringed planet through a telescope, spare a thought for the lonely traveler 13 million kilometers away. It is still there, prowling the darkness, slowly spray painting the heavens and keeping the secrets of the primordial fire that built our home. In a universe this vast and this ancient, perhaps the only thing more mysterious than the objects themselves is our own relentless need to understand them. What other secrets are hidden in the shadows of the giants, waiting for us to finally turn our cameras toward the dark?